ಅಟೆಂಡೆನ್ಸ್ ಹೆಂಗಾಗಿರುತ್ತೆ ಗೊತ್ತಾಗತ್ತಾ? All of you please mention name and USN in the chat box. Next, come to the point, the limit gauges. The limit gauge means there will be two. One is go, other one is no go. The name itself indicates go. If there will be a hole in the shaft, there will be a hole in the casting. If you insert the gauge, if it moves easily in the hole, then it is called go. Suppose if you have difficulty of inserting the shaft in the hole, then it is called no-go gauge. Only two criteria. One is go, other one is no-go. So by using the criteria of go and no-go, the name itself indicates go. That is easily moves inside the hole. Then clearance fit exits. Suppose there will be difficulty in passing the shaft in the hole, then it is considered as no-go. There will be two criteria. One is go, other one is no-go. This is very much essential for machining of shaft and drilling of hole in the casting, as well as machining of shaft in the machine shop by using lathe. Next, come to the point. This is called plug gauge. This is called plug gauge. This is go gauge. This is no go gauge. And this is the component. This is the component. And then if the go gauge moves easily inside the hole, then it is called go gauge. There will be little difficulty passing the shaft in the hole, then it is called plug gauge. Then it is called no go gauge. No go gauge. All of you observe here. This is lower limit and this is upper limit. So in the upper limit, there will be difficulty of passing the gauge, that is called no go gauge. If there will be no difficulty, the gauge can be easily passed in the hole, and then it is considered as go gauge. All of you observe here, the gauge, the plug gauge, go, no go plug gauge, which is used in the metrology lab, looks like this. Look like this. One end is go gauge, other one is no go end, or go end or no go end. And this is manufactured from low carbon steel. Remember, this is manufactured from low carbon steel. And the handle is manufactured from soft material, metal like aluminum, brass, sometimes wood are used for making of handle. There will be two ends. One is go end, other one is no go end. Say, using this gauge, you can check the hole diameter, check the hole diameter. If it is produced according to the go dimension, then go end passes through the hole easily. And if you face little difficulty of passing the go, no go end in the hole, then there will be oversize, or there will be little over dimension is there. Then it is called no go end, which is not passing through the hole. There will be two criteria. One is go, other one is no go. This is called double-ended plug gauge. Double-ended plug gauge. Say the same type of gauge we are using in the metrology lab. I will show you this gauge in the metrology lab. Once again, the go and no go gauges are manufactured from low carbon steel, and the surface is finished, polished, and provided the mirror finish, because the go end and the no go end should passes through the hole. For that reason, the surface should be hardened, stabilized, and finished up to 600 HV and heat treated. And the surface is tempered, hardened, and stabilized, because of there will be a metal contact between the hole and the gauge. For that reason, the go and no go gauges are heat treated up to 700 HV, stabilized, tempered, and provided smooth finish on the diameter or surface. This is plain plug gauge, double-ended plain plug gauge. Say one more gauge is there, that is go and no go end. That is called progressive plug gauge. Here the go and the no go gauge passes through the hole at a time. Then if you feel easy while passing the go end, and the same time if you feel no go end a little bit difficult to pass the no go gauge, then it is called the hole is finished according to the dimension. There will be a over dimension. If you feel easy in passing the go end, then the hole is finished according to the dimension. Their clearance fit exists. Their clearance fit exists. And next come to the point. In the same way, you are producing shaft using lathe in the machine shop. Shaft using lathe turning operation. You machine the shaft. Say ring gauge. The name itself indicates, observe here, there will be two rings are present. One is go gauge, other one is no go gauge. And this is the shaft. Say the shaft is turned in the lathe, and if you pass easily in the go gauge, then the clearance fit exists. Then you have little bit difficulty in passing the shaft in the no-go gauge, then the shaft is finished above the upper limit. Then it is called go gauge, no-go gauge measurement. So for that reason, always the go gauge is for clearance fit and no-go gauge for interference fit and transition fit. If you feel the shaft easily passes inside the go gauge, then it is called go gauge, and here you have clearance fit. In this no go gauge, you have interference and transition fit, and the shaft is machined above the upper limit of the shaft, above the upper limit of the diameter. All of you observe here, lower limit and upper limit. Again, these go and no go gauges are also manufactured from carbon steel, low carbon steel, heat treated up to 700 HV and heat treated 700 HV, stabilized, finished, smooth, and surface is made. Smooth surface finish is provided on inside the ring edge. So because of the inside surface which is passes on the shaft, for that reason there you require the temper in the inside surface. For that reason the inside surface is heat treated up to 700 HV, stabilized, heat treated, polished inside the surface of the go and no go gauge. Next come to the point, snap gauge. Snap gauge. This is used for checking of diameter of the workpiece. All of you observe here. Okay, this is the component produced using lathe or machining center. Here, the snap gauges are available in the range of 3 millimeter to 100 millimeter and 100 millimeter to 250 millimeter. You can consider according to the diameter of the shaft or according to the thickness of the sheet. You can consider or select the snap gauge. All of you observe here, this is the real snap gauge used for measuring the diameter of the component which is produced in the lathe. Which is produced in the lathe. See, only two criteria. One is accept, other one is reject. See, all of you observe here. This is other type of adjustable gap gauge. So according to the gap, you can use two. See, all of you observe here. This is go gauge. Other one is no go gauge. See, if the diameter accept the go gauge diameter, then clearance fit exists, or this is for measured. This is made for the lower limit and the upper limit. Then sometimes this gauge is used for checking the diameter of the shaft. If the shaft is above the dimension or oversized, then it is called go, no go dimension. Then reject the shaft. So only two criteria. One is accept, other one is reject. So this type of snap gauges are available in the market according to the requirement in the machine shop. You can use the snap or gap gauges. See, there will be three types of gauges are available in the market. That is double-ended. One is for go, other one is for no go. In the same way, progressive, the name itself indicates progressive. One end for go, other end for in the same place you have go as well as no go. And this is the adjustable gap gauge. And some of the properties and desirable properties in the gauges: plug go no go plug gauge, go no go ring gauge, and snap gauge. In the examination you may have the question like this. Please all of you write down. All of you please write down. Explain briefly limit gauges. Limit gauges. Put a question mark. After that, write down in bracket. After that, write down in bracket. Explain go and no go. Explain go and no go criteria. Close the bracket. Close the bracket. Next, write down. Explain briefly. Explain briefly with neat sketches. Explain briefly with neat sketches the following. Neat sketches the following. Below that, write down number 1, plug gauges. Below that, write down subdivision. Number 2, ring gauges. Ring gauges. Next line, write down subdivision 3, snap gauges. Mark it very, very important. Almost all the question paper, you have this question. Mark it very, very important. Almost all the question paper, you have this question for 10 marks. For each type of gauge, write a minimum 2 diagram and explain. For plug gauge, ring gauge, and snap gauge, you must write 2 diagrams. 2 diagrams. And say here you have few properties which is very much essential for gauges. That is stability, corrosion resistance, machinability, and low coefficient of friction, as well as low coefficient of thermal expansion in low temperature as well as in high temperature. High temperature. These 5 properties are very much essential. Please, all of you, consider the desirable properties of gauge materials. Next, come to the point, different types of materials used for manufacturing of gauges. That is high carbon steel, and here they have not mentioned low carbon steel. So usually the low carbon steel is used for making of gauges, and mild steel, case hardened steel, chromium plated steel, cast iron, glass, and inward usually used for making of gauges. And all of you write down, very, very important, write down the title. Write down the title, Tyler's principle of gauge design. Tyler's principle of gauge design. Say, till today, in manufacturing of ring gauge, plug gauge, and snap gauges, we are using Tyler's principle. Tyler's principle. The Tyler's principle states that the go end of the plug gauge should check one dimension at a time. Remember, all of you, the go end of the plug gauge or the go end of the snap gauge should check one dimension at a time. The hole in case of plug gauge and the concentricity or cylindricity of the shaft by using the snap gauge or ring gauge. So that is very, very important. The go end of the ring gauge, go plug gauge, go snap gauge should check only one dimension at a time. In case of plug gauge, should check circularity, concentricity, ovality, straightness of the hole. Straightness of the hole. And in the same way, the no-go plug gauge should check one dimension at a time, only one dimension at a time. That may be concentricity, ovality, straightness, and the machining of the hole, ovality of the hole in case of plug gauge. So that is nothing but the go limit and no go limit. Go limit and the no go limit. For that reason, in case of plug gauge, go end should check one dimension at a time. No go end of the plug gauge should check one dimension at a time. In the same way for snap gauge and also for ring gauge. Till today, we are using the same Tyler's principle for manufacturing of gauges. manufacturing of gauges. So the economy of the Taylor's principle based on bathtub curve, that will I will give you in the next class or later classes. Bathtub curve. If you consider the cost of rejection and the cost of gauges, if you plot the values in XY direction, the cost of rejection, cost of the gauges, from that you can calculate the total cost of the gauges, total cost of the component. From that you will get maximum productivity. The definition of the productivity is by using the resources available in the industry. From that you can make the maximum profit. That is called productivity. If you use the gauges conveniently, economically in the manufacturing, automatically the productivity of the industry increases. Productivity of the industry increases. That is the go end and the no go end should check one dimension at a time. From that, you can check the ovality, straightness, concentricity, straightness of the hole in case of hole in the casting. In the same way, the diameter of the shaft, straightness of the shaft by using ring gauge. In the same way, if the diameter of the shaft by using snap gauge should check, the go end should check only one dimension at a time. At a time. Today, I stop at this stage and I will continue in the next class.